Hey, good morning, guys. These are our notes for today on Newton's laws. I'm doing these at a fabulous 4:15 in the morning. As you can tell, it's still dark outside behind me. But hey, what a better time to do notes than early in the morning? So I'm going to hide this right here. So these notes today are on Newton's laws, which we've been covering in class and doing all those fun activities. My headache finally went away from that hammer activity we did the other day. So I had a headache for a couple of days, but it's finally gone. So that is a good thing. So I got a lot of things open here on my desktop. So first thing we're going to go to, and I don't have it on here actually, but what I want you to go to is your table of contents and put in today's dates, the 7th, November 7th, and label it Newton's Laws, and wherever page you left off on, that's what you want to put down for the page number. So again, go to your table of contents, News Laws, today's November 7th, and whatever page you left off on. So our first page of notes, I'm going to open up here and make nice and big for you guys. Hopefully you can see me while we're doing this. There we go. You might not be able to see me, but that's okay. So our first set of notes here, right here, we're going to do law number 1. So law number 1, we did some fun things with that, with the pennies, the cups, and the note cards. So all law number 1 says is an object in motion will stay in motion, an object at rest will stay at rest. And until a force is acted on them, a greater force is acted upon them. So here's a picture of a car, and we were talking about this. The car has a force being acted upon it, which is that brick wall, but the person inside does not have that force acted upon them. So that person will still stay in motion until that person actually themselves would hit that brick wall. All right. And also we talked about inertia. So here's our cup activity with our card and our pennies on top of the card. Actually, these are our eggs from the beginning of the year. These are eggs on top of the cardboard tubes, on top of the cardboard, on top of the cups. So when we apply a force to the card will fly, it will move, it'll change. It was at rest, now force acted upon it. However, the eggs' inertia will stay the same and gravity will pull them down and they'll fall into the cups. Okay? And here's our penny on the card activity. That's my hand. All right. And flipping the card out, the penny will drop inertia. The penny's inertia will stay the same and it will fall down or stay on your finger. And the other term for inertia, what we want you to write down, so let me pull that up here. Here I am again. So I had a couple images for inertia here. So in your notes here on that same page, you could, right next to inertia, you can put the definition is to stay in motion until it acted upon by an external force. So here, this gentleman, not so lucky that day. He ran into the wall, so that motorcycle stopped, all right? It's not going anymore, all right? It was acted upon by external force. However, he is still going, all right? No force has acted upon him yet. He was on that bike, but the bike was acted upon by the external force, which were these tires. This gentleman right here, he's not having a good day. He is still going, all right? So this is a good definition for inertia to put into your notes. To stay in motion until acted upon by an external force. I'm going to show you one more picture of inertia and some more stuff I want you to write down for it. So hang tight here. Let me find it in my chaos of stuff. So we're going to take this out. Again, pause the videos if you need to. So I'll get him out of here. Here we go. So this was our cup with our coin on top of a note card. So when you pulled that cardboard, the coin fell into the glass. This is because the inertia of the coin maintains its state at rest. We didn't touch that coin. It was still at rest and it fell into the glass. Only reason it fell down in the glass because of gravity. All right. So we applied a force to that card. All right. The force was only applied to that card. The inertia of the coin stayed at rest. All right, nothing changed to that coin. That's why it fell into the glass. And that was all due to gravity. So in your picture, which you already drew in your notes, you could add this little paragraph underneath it to help you out. So again, pause the video if you need to. I'm going to go on to our next page of notes. All right, there I am again. I told you it's chaos here on my screen. So let's get rid of this. We got Newton's first law already. We took care of that. And after Newton's first law, of course, is Newton's second law. Let's see if I can zoom in and you guys keep my lovely face on this page. Yeah, that doesn't look good. So we'll make it nice and big. All right, so for Newton's second law, remember there is an equation. So that equation right here was F equals ma. Force equals mass times acceleration. We could also change that around. We know from our algebra class. We could have acceleration equals force over mass. So the acceleration of an object depends on force and its mass. And we saw that in some of our examples we were doing in the hallway with the different size objects and the ping pong ball and the golf ball with the ruler. Acceleration, the more force we use, the more the object will accelerate. All right. And force, if an object has a larger mass, we have to use more force to get it to accelerate. So that was an example of the ping pong ball and the golf ball. That golf ball needed a little bit more force to get it moving compared to the ping pong ball. All right. The masses were different. The golf ball had more mass than the ping pong ball. Another good example is our grocery store model, which we didn't do in class. This would be fun to do next time. Everybody likes to be a kid at the grocery store. So we have an empty cart. We haven't got any groceries yet. Then once we start shopping for our families, all right, or for ourselves, we start to fill up that shopping cart. We go on a shopping spree and gets more and more and more items in the cart. So usually like what I do at the grocery store, when I have an empty cart, I jump on the back of it. It moves really easily. However, once I get more and more stuff in there, it's harder for me to move that cart and have fun and fly up and down the aisles. So the empty cart will be easier to move because it has less mass. All right. It'd be able to accelerate a lot faster. So this is our grocery carts demonstration here, coming to you in 2020, hopefully down here in the hallway by our classroom. So again, pause the notes if you need to. I'm going to zoom out here. These are our notes for Newton's law number 2. Let's close those out. There I am again. And we're going to move these out of the way. And we have one more page we want to cover. Let me open that up. And this is for Newton's law number 3, which we covered yesterday out in the hallway using a skateboard. And we had Newton's cradle also. So what we want you to remember for Newton's law number 3 is for every action, there is an equal and opposite reaction. So we got a couple pictures for you and a couple explanations. So right here, this is a gentleman on his lovely canoe out on the water, out on Lake Michigan on a nice summer day. So what happens if you stood on the back of your canoe and your canoe was going in one direction, started to go in one direction, you did not know it? You would go in the opposite direction right into the water. So that's what we want you to draw here. So this is our water. This is our boat going to the right. And as it moves to the right, the person on that back of the boat would fall because he would start moving to the left. All right. So for every action, there's an equal and opposite reaction. And we also talked about normal force yesterday in class. So when you're sitting on your chair, or when I was standing on a chair, so this is me, this is a chair, I'm applying gravity force, or the force of gravity is pulling me down, and normal force is pushing up on me from the chair. So what this means is every surface has a normal force. All right. So if you're sitting on your couch at home, like I'm doing right now, it's applying a normal force to you while the gravitational force, gravity force, is pulling you down. So what we want you to remember is every surface has a normal force. Okay. Let's go down here. These are our notes for universal gravitation. This is what we did before you got into Newton's 3 laws. This is when we had you drawing in the hallway On the windows, talking about the force equals mass 1 times mass 2 divided by distance squared times the constant of g, and we took out that constant for the fact of our class. We didn't need that. So this was called the law of universal gravitation. Every object attracts each other with a force. So this is our sun right here, and this is our earth. And each has a normal force pulling on each other, but the gravitational force would be greater coming from the sun than a gravitational force coming from the earth, because our sun is a larger mass. More mass, more force. We also learned with the law of universal gravitation, if we increase the distance between two objects, the force will go down. All right, so if we increase the distance between Earth and the sun here by 2, the amount of force will go down by a factor of 1/4. Okay? And these are our notes. Pretty much we had our 3 laws, Newton's first, second, and third, and the law of universal gravitation. What I'm going to show you right now is a quick video on some more real life examples of Newton's laws. So let me close this out. Make this bigger for us. And please watch. This is just a couple minutes. Oh, I lost my screen. Almost lost where I was on my camera. So let me play this for you guys.
Welcome to Moo Moo Math and Science. In this video, I'd like to talk about some real-world examples of the 3 laws of motion. Sir Isaac Newton, who lived in the 1600s, developed 3 laws to describe all states of motion. In this video, I'd like to look at some real-world examples. Let's start with Law 1. Law 1, or the law of inertia, states that matter wants to resist any change in motion. The speed or velocity of a motion will not change unless an outside force acts upon it. For example, this bowling ball would travel in a straight line forever, but the friction of the floor and the air, plus striking the pins, change the velocity of the bowling ball. Astronauts appear to float in space because there is very little gravity pulling down on them in space. So when they change their velocity upward, the force of gravity is not pulling down on them, and they can float. And finally, if you're driving a car and it hits another car, the car stops, but the people inside keep moving forward. That is because the outside force is acted on the car and not the person inside. This is the same way a catapult works. The lever stops, but the object keeps moving. Law 2 states that the acceleration of an object depends on the force acting on it and the mass. And there's an equation, force equals mass times acceleration. Think of a shopping cart of groceries. The mass of an empty shopping cart is much less than a full shopping cart. So it takes much less force to push an empty cart compared to pushing one that is filled up with stuff. And finally, Law 3 is for every action there's an equal and opposite reaction. As this boy jumps down on the trampoline, the trampoline pushes back in the opposite direction and causes the boy to move in an opposite direction. Also look carefully at this balloon. The balloon is falling downward, and then it hits the ground, and the ground is pushing in the opposite direction and causes the direction of the balloon to change and move back upward. So there we go, some real-life examples of the 3 laws of motion. Thanks for watching, and Moo Moo Math uploads a new math and science video every day. Please subscribe and share.
All right, so there were some real-life examples, and some of those examples I actually talked about in the notes. So again, those are Newton's 3 laws, and we also talked about the law of universal gravitation. Hopefully these notes helped you out. If you're still a little confused, please let us know. We are always here for you. Get these into your notebooks. Again, Newton's laws, Newton's 3 laws, and the law of universal gravitation. Later.